All right, let's just jump right in. We're going to peel back the curtain on something you probably do a dozen, maybe 100 times a day without even thinking about it. Hitting send.
Now seriously, think about that for a second. You click a button, right? And poof, your message just appears on a screen maybe halfway across the planet, instantly. How does that even work? Well, it feels like magic, but it's not. It's actually one of the most incredible, most resilient systems anyone's ever built.
Okay, so the first thing you gotta wrap your head around is this. The internet, it's not one single thing. It's not some huge computer sitting in a bunker somewhere. Nope, it's actually a massive network of networks. Just tons of them, all connected. And they've all agreed to play by the same rules, to speak the same language. And that agreement, right there, that's the whole secret.
So, to really get how your email zips from your screen to your friends, we have to follow this amazing little journey. The journey of something called a packet. I love this analogy. It's perfect. Imagine you built something amazing out of Legos and wanted to mail it. You wouldn't just throw the whole thing in a box, right? It'd break. Instead, you take it apart piece by piece. That's exactly what the internet does with your message. It doesn't send it as one big chunk. It shatters it into thousands of tiny little pieces. So you've got these 4 steps. And step 3, that's where the real magic happens. Each one of those little Lego bricks, those packets, they go off on their own adventure. They don't travel in a convoy. Each one gets a label with the final address, and then it's like, good luck, find the fastest way there. This means they can totally show up out of order, but that's okay, because each one knows its place, and they all get snapped back together perfectly at the destination. So how in the world do they know where to go? Well, it's basically Google Maps for data. Seriously, it's called dynamic routing. If one path is clogged up with digital traffic, or, a connection is just totally down, the system doesn't panic. It just says, okay, rerouting, and finds another way. And this isn't happening once or twice, it's happening millions of times every single second all over the globe. Okay, this is a super important point because we all get this wrong. We say internet and web like they're the same thing. They're not. Think of it this way. The internet is the actual physical stuff. The cables under the ocean, the routers in your house, the cell towers. It's the entire system of roads. The web, on the other hand, is what uses those roads. It's the websites, the videos, the stuff you're looking at right now. It's the cars driving on the roads. All right, so you've got this unbelievably complex system, millions of pieces all working together. You'd think it would be breaking down constantly, right? But it doesn't. And the reason why is kind of mind-bending. The internet was actually designed to fail. It was built with the expectation that parts of it would always be broken. And that, believe it or not, is its biggest superpower. I mean, just imagine it. Some huge cable at the bottom of the ocean gets snapped by a ship's anchor, or a massive server center has a power outage. For most systems, that's game over. Catastrophic failure. But for the internet? It barely even notices. The data just finds another way to go. This amazing ability to shrug off damage is called fault tolerance. And the reason it can do that is because of this key idea, redundancy. It's so simple when you think about it. If the main road you take to school is blocks, you don't just sit there, right? You take a different street. Well, the internet is built with thousands, millions of extra side streets just in case. So that's the bottom line. Redundancy. It's the secret sauce. You basically build more than you need. More paths, more connections, on purpose. That way, you pretty much guarantee there's always another option. It's not reliable by accident, it's reliable by design. Okay, so now that we know how the network stays up and running, let's talk about how we use all that power. How this structure lets us solve enormous problems that would just crush a single computer.
This table lays it out so clearly. First, you've got sequential. That's doing one thing at a time. In order, the lonely worker building a house all by himself. Then there's parallel. Now you've got a whole crew. 5 workers, all building different parts of the house at the same time. Way faster, right? And then you have distributed, which is the whole shebang. Now you've got teams in totally different cities, all working together, coordinating to build that one house.
And this idea, this working in parallel, or in a distributed way, it's what makes so much of our modern world possible. We're talking about everything from predicting hurricanes to rendering the graphics in your favorite video game, and there's actually a name for that performance gain you get. It's simply called speed up. So let's say a single computer takes 10 seconds to do something, but you throw 5 computers at it, working in parallel, and they knock it out in just 2 seconds. That's a 5x speed up. That is the incredible power of teamwork, but for computers. Okay, wow. We have covered a ton of ground here, so let's just pause and boil it all down.
If you're going to remember just 3 things from all this, make it these 3. This is your study guide.
First question. You know when you're loading a web page and the image kind of appears in weird blocks, or a text seems to get jumbled for a split second? What's up with that? Why does it happen? It's super simple. The packets took different routes to get there. Some took the scenic route, some took the highway. They just arrive when they arrive, and then they get reassembled.
All right, number 2. We hear about big server outages all the time, right? But for you and me, the internet, it just kind of keeps working. How is that even possible?
It's all about those 2 key ideas we talked about, redundancy and fault tolerance. There are extra paths built in, so when one road closes, the system is totally fine. It just reroutes. It was designed for things to go wrong.
And last but not least, the big one. If parallel computing is so awesome, why can't we just solve every problem instantly by throwing like a million computers at it? Because some things just have to be done in order. Think about baking a cake. You can't bake the cake 10 times faster by using 10 ovens if you haven't even mixed the batter yet. Mixing the batter has to happen first. That's a sequential step, and it's a bottleneck. More computers or more ovens just can't speed that part up. So that really leaves us with this final kind of cool idea to chew on. The internet, one of the most powerful inventions in human history, isn't some perfect, fragile machine. It's this messy, flexible, almost chaotic system that's built on a few simple rules, and the core belief that things are always going to break. And maybe, just maybe, there's a lesson in there for how we build other things in our lives, not just technology. Something to think about. Thanks so much for joining me.